Hello everyone, welcome to another episode of Special Sevens. Welcome Indra and Netra. Thank you for being a guest in our show today. Today we have a very interesting cold topic, snow time. Only this month or last month we got the first snow in Vancouver. Let's learn a little bit more about snow. Are you guys ready?
Yep.
Okay. First of all, what is snow? Snow is frozen water, right?
Yeah.
Is that a better way to put it? Just like rain, snow starts as a tiny water drop, right? But when the temperature is below 0 degrees Celsius, which is the freezing point for water, it crystallizes or it becomes a solid. So from liquid, it changes to a solid state. So why is snow white? Water is clear, but snow is white because water is transparent. And snow, as water becomes a solid and a crystal, it reflects more light than water. So that's why it mixes all the reflected lights. When you mix all light, what color do you get? White. That's why snow is white. So why is snow soft? Let's say it has snowed fresh and you go and scoop in your hand. Is it hard as a rock or is it soft? Why is it soft? Because of, yes?
If there's not that much water in the clouds, then I don't know actually.
It's because of air pockets, just like your sponge.
What about hail then?
Hail doesn't have enough air in it. If you take a little bit of snow in your hand and if you press it and make it a snowball, which is when all the air escapes, then it becomes harder, right?
Yeah.
Easy to hit each other. So now you guys know why is snow white and why is snow soft, correct?
Yeah.
Now let's look at snowflakes. Snowflakes have these interesting patterns, right? They are like crystals and that's why they reflect more light than water. It all starts with a single molecule and a single crystal, which is very tiny, and as it falls along the sky, it collects more snow or more water vapor and freezes it more and it slowly grows. It always has this six-sided hexagonal shapes. Snowflakes always form these interesting shapes. It's almost like your Lego bricks. You can only join two Lego bricks in a particular way, right? That's an example of why water always forms these shapes, because these molecules attract each other in a particular way.
Do all snowflakes look the same?
No two snowflakes will look the same.
But all of them are similar?
Here you can see in the screen different crystals, right?
Yeah.
They could be in any of these patterns, but if you look into them very closely in a microscope, they will all be different. Almost like our thumb. Even though there are so many people, everyone has unique thumbprints, right? Another example is like baking a cookie. It's the same batter, but then after you bake, all the cookies look different, right? So why do they form these unique shapes? Let's look at the water molecule. What does the water molecule have? It's H2O, 2 hydrogen and 1 oxygen. When the temperature reduces, you see how the free flowing water molecules, when they all crystallize, they all form these shapes. The bonding that gives this shape. So oxygen is negative, okay, and hydrogen is positive. So they act like tiny magnets and they all bond with each other. Imagine playing with 4 or 5 magnets and they always stick together and they try to form a bond, right? That's what happens. When the temperature reduces, these molecules crystallize and form the snowflakes and these unique shapes. And they attach each other and they bond. So a single molecule bonds itself and then it gradually grows and the snowflake becomes bigger and bigger, molecule by molecule. So it starts from the inside and it slowly grows outside. But think about an ice cube from our fridge. Why is it not forming these unique shapes? Why is it not like a snowflake?
Because
we pour it into molds, correct? And another way to explain it is, we pour it into a mold and we try to reduce the temperature in the fridge, right? Yeah. So they crystallize from outside to inside. So the outside water molecules first crystallize while the inside water molecule is still a liquid, and then it slowly grows outside to inside. So that's why when you lift up an ice cube and see, you will see air molecules in it. Correct. Snowflake inside to outside, that's how it crystallizes. But an ice cube, it crystallizes from outside to inside, trapping the air molecules. So since ice cube is trapping all these molecules, it can also trap dirt and so on. It's not the most pure form of water. Unless you boil the water before you make ice cubes, then it will be good. But since snowflakes, they start from a tiny water molecule and they grow and they only attract other water molecules, they are very pure. So if you go outside on a snowy day, you can open your mouth and drink it. You are drinking pure water. But when it hits the ground, it's going to pick up dirt. Okay? So don't eat snow from the ground. Okay, good. Let's proceed to the next interesting topic. Snow salt. You might have seen me shoveling our driveways and then putting salt, right? Why do we do that?
To keep us from slipping.
Yeah, and
Correct.
because the salt melts the snow.
The snow salt does not actually melt the ice. What it does is, it goes and prevents these water molecules from bonding. Imagine you have few Lego blocks. I put some stones in there. Would you be able to join the bricks again?
No.
The stone is going to stop them from bonding, right? That's the effect the snow salt does. For a water that has salt, 0 degrees Celsius is not enough to crystallize. It has to go to, let's say, minus 20 degrees. But when it's usually snowing outside, it is only 0 degrees or minus 1 or minus 2. So the salt does not allow the water to crystallize, so it doesn't become snow and it just runs away.
Isn't it already crystallized when it falls though?
Correct, there is already snow, but then this salt is gonna melt and then it's gonna break the bond. There are a few advantages and disadvantages to using a snow salt. First thing is, it is a very economical way of cleaning our driveways. Just like Netra said, nobody is going to slip and fall because there is no snow. The negative impact is sometimes the salt will damage the road. The salt is going to also have an effect on the road and it's going to break it eventually. Other thing is, it's going to melt and run away and harm all the plants that live around that area. And if it ever reaches the water, it is going to pollute the water and it's also going to harm the fish in the water. One more negative impact of snow salt is sometimes our pets, when we take them out for a walk, they might lick it and it might have some negative effect on their tongue or on their health. What are the alternatives though? We could use beet juice. Beet juice also surprisingly has the same effect. It's not gonna let the water molecules bond, it's gonna melt the snow, but it's not very cost effective, right? But it's not gonna pollute the river or the plants.
And you might still slip on the juice.
The other alternative is sand. Sand is gonna create friction. Also ash is another alternative.
Nobody wants to pour ash on their road or whatever.
Correct.
And plus you'd have to burn the wood to get ash.
Correct. Imagine they are selling an alternative solution. Just like how we go and buy salt from store, we could also go buy these and use it. They are also cost effective and they don't have any negative damage on the environment, right? Okay, so now you guys understand what is snow, why is it white, and you also understand why it always forms these interesting shapes, crystals. You understand water molecules and how snow salt work, right? So I have a question for you. What is black ice?
Very slippery ice.
Ice, correct? Why is it called black ice?
Because it looks black.
Is it like ice that's like on a black road?
Exactly. After a snowy day, let's say the snow is powdered and we all walk on it. So all the air pockets or the air molecules escape. So it is compressed snow. And overnight the temperature increases a bit, so it becomes water again. And then the temperature reduces again. So now this compressed thin layer of snow forms. and it becomes black ice. It is even more dangerous.
Also,
Because, yes?
or whatever, so then the sun like melts like the top layer and then it becomes water and like slippery.
Correct.
And it's even more slippery than like regular ice, like on a white sidewalk or
Correct. And it's more dangerous because we can't see it, right? We think it's just the road. Okay, good. Now it's quiz time. What is a water molecule made of?
One hydrogen, one.
So you just say H2O.
Yeah.
Okay, perfect. So 2 hydrogen and 1 oxygen. Perfect. Though water is clear, why is snow white?
Because it, like all of the color mixes in the snow.
And it reflects.
Correct. Reflex is the key word. And then the second
And
part
then it
is?
just becomes white because all the colors make white.
Correct. And one more point you could add is, why does it reflect color so effectively? Because of the crystal shape, right?
Yeah.
All these interesting shapes, then it reflects light more effectively. How does snow salt work? So it actually reduces the freezing temperature. That's the correct answer. So name some alternatives for snow salt.
Beaches, ash.
And sand.
Yeah, and sand.
Okay. But that brings us to the end of our show today. We learned a lot about snow salt and snowflakes and crystals. Hope you all enjoyed the episode. Before we conclude the episode, I will leave you guys with an interesting question to think about. How do isolated lakes get fishes? Imagine a lake which is away from all other water bodies, but still how do fish reach there? Think of the answer for this question. We will reveal the answer in next week's episode. Until then, take care. Thank you, Indra and Netra, for being part of the show. Bye, everybody.